Example 5, compressibility. One of the quantities of interest in thermodynamics is compressibility. If a given substance is kept at a constant temperature, then its volume V depends on its pressure P. We can consider the rate of change of volume with respect to pressure, namely the derivative dV divided by dP. As the pressure increases, the volume decreases. So the derivative is less than 0. Now the compressibility is defined by introducing a minus sign and dividing this derivative by the volume V. So the isothermal compressibility is equal to the Greek letter beta, which is equal to -1 over V times the derivative of V with respect to P. Thus, beta measures how fast per unit volume the volume of a substance decreases as the pressure on it increases at constant temperature. For instance, the volume V in cubic meters of a sample of air at 25 degrees Celsius was found to be related to the pressure P in kilopascals by the equation V, which is equal to 5.3 divided by P. Now, the rate of change of V with respect to P when P is equal to 50 kilopascals is the following. So, let's take a look at this function. What we want to do is we want to find the derivative of V with respect to P of the function 5.3 over P. Now keep in mind that this is equal to, if we want to rewrite this as 5.3 P to the -1. So if we go a little further, if we take the derivative of that, then we get -5.3 P to the -1 minus 1 is -2. So now we want to evaluate this at when the pressure is 50 kilopascals. So if we let P equal 50, we're going to plug it into the derivative function, so it's -5.3 times 50 to the -2, or this is the same thing as -5.3 divided by 50 squared, which is 2500. Well, that's going to give us the following answer. -0.00212 cubic meters per kilopascals. So therefore, that gives us the following answer. Now what we want to do is we want to find the compressibility at that pressure. So what we're going to have to do is use that formula that we have. And so the compressibility is what they have, that formula for beta. And that formula for beta is -1 over V times the derivative with respect to P. Okay, so what do we know? We know that V is equal to 5.3 divided by 50, and we know that dV of dP is going to equal -0.00212, and now we're going to plug it into the formula. So B is going to equal -1 divided by 5.3 over 50 times negative 0.00212. Okay, and if we simplify this a little further, that means we're going to have 50 in the numerator times 0.00212. Since a negative divided by a negative is a positive, or negative times a negative is a positive, and divide that by 5.3. So therefore, we get 0.02 cubic meters per kilopascals per cubic meters.